General Protocol Spaces, banking on freedom.
Let's get this party started. So welcome to General Bull number 53. Sorry about last week. We had circumstances that couldn't be avoided, and we had to delay it to this week. But same topic this week. So we're going to get back onto our very technical topic that we started in the previous one. And that is going through this article, The Vision to Reality of XO. So we've talked many times about XO, but here we're going and actually walking through what the parts are of XO, what they do, and how a normal transaction works, and hopefully a little bit about the contrast between what systems that do today, like what a wallet might do today, versus what the XO system is doing, and how they're different, and why they're different, and why that's important. But at least it's going to be a walkthrough of what a real transaction looks like, and I'll link this article in the thread on Twitter. So if you aren't aware of it, look it up. If you want to just go there right now, it's stack.xo.cash/blog, and you can find the article there, Vision to Reality. All right. So today we have imaginary username and Jonathan. Jonathan is the article of, Jonathan is the author of the article, and he's going to be the main person walking us through today. So last time I believe we got through just the introduction, right? Which introduced the parts of the XO stack, some of the main parts of the XO stack. Could you just give us like a 1-minute recap, Jonathan, on what those parts were that we went through?
All right, we were talking about the engine, the templates, and an inviting system. And so the engine, it tracks state, it tracks keys, it tracks secrets. It's the one thing that everything is going to interact with and talk with. The engine uses templates. Templates are a description of use cases, and they define how to create transaction and other types of data. So template, they encode all the domain knowledge of making interactions on BCH, and also some domain knowledge of the actual use cases themselves. Last, we have invitations, which is a coordination mechanic that the engine uses that allows one or more participant to define what they are about to do and to collaborate if they want to do it together with someone else. And all of these things revolve around like the templating system.
Great summary. I've actually invited a couple of people in the audience up. So hopefully you guys can serve as helping us have questions if we're not covering things well. But from my perspective, who has maybe not the best perspective because I've thought about this stuff a lot already, that was a great summary. Thank you, Jonathan. Let's see if anybody joined us yet. Okay, not yet. So we may come back to some topics if somebody joins us and starts asking questions. But yeah, let's go ahead and get into it. Let's get into the article. So what is the transaction that we're talking about? What is the basic thing that we're doing in this article, Jonathan? And could you get us started on the walkthrough?
Yeah, so in this article, we are going over the process by which one party coordinates a transaction with another party. And what we are doing is we're taking a not very basic just send some satoshis, but we're actually trying to showcase some of the features of the templating system. So we're setting up a transaction where we request 100 MUSD. So MUSD is a stable coin. And to do so, we go over how it might look like in code to go through the steps required to start up the engine, initialize your networking, and get to a point where we can start using these templates.
Fantastic. So the use case here is, for example, you're running a retail shop and somebody wants to pay, and your store prefers to accept things in USD terms. So it accepts a stable coin, in this case, one called Moria USD, MUSD. So they'd like to receive 100 Moria USD, and this is the process of how that actually happens with the XO stack. Is that right?
Yes.
All right. Let's go.
All right. So, um, yeah. So it's kind of hard to like go through and describe the actual code over voice. So I'm not gonna go through it in like that kind of detail, but I will say that yeah, the first thing you need to do before you can use the EXO engine is that you need to start the engine up, right? You need to initialize it, and with that, you need to provide it some specific um, functionality that it's going to need to do. One of
And
the
who are
things
we
it
talking
needs,
about here? We're talking about the merchant, right?
right?
For example, in this case.
So
Yeah.
it's actually both sides, right? So whoever wants to interact with the templating system that and chooses to rely on the EXO engine libraries to do this, they will have their own copy of the engine running, right? So if you have a wallet that's gonna handle the payment request, you will have a copy of the engine running on your end set up for you. And if it's a merchant trying to get 100 MUSD in this example, then the merchant will also have a copy of the engine running on their side with their data in it. And so the setup is going to look the same for both of these parties and also for any intermediary apps or third-party things. So there's more things than just the wallet and the payment process that might use the engine. But the parts that the engine is going to need is that first of all, because it needs to be able to generate private keys and identities, you will need to provide it some kind of seed entropy, like some kind of secret that you can start from. This is the equivalent of the 12 words that are used in many backup schemes. And in fact, the 12 words are actually just a description of such a seed with the 12th word being some, I forgot the term for it.
Entropy.
No, the 12th word isn't entropy at all. It's actually just to verify that they haven't entered the data incorrectly. Parity, some parity information. So anyway,
Checksum. Okay. Anyway.
yeah, a checksum. Checksum is a fine way to say it. So yeah, you need to have a seed. So in the merchant's perspective, they would reuse the same seed and they have it in some kind of automated system. In your wallet, it would have its seed, and every time you start out your wallet, it would take the seed and provide it to the engine so the engine can work with it. The second thing you're going to need, the engine is going to need, is information about what's on the blockchain, what's in the mempool, and how are things changing over time on the blockchain side. And so it needs some kind of network connection to an indexing server or some other way to get blockchain information. And the third and final thing it's going to need is a place for it to store information. So the engine is going to manage a lot of data, and it's going to ensure that that data is being handled well, it's kept secure, but also that it's not going to be lost in some way. And to do this, it needs a persistent storage mechanic. And so you need to provide it where it should store. The setup we are going to go for is not one that uses a single storage. We're going to have multiple storages to have redundancy. But for the sake of explaining how to start up the engine, what you need is the seed, you need a way to check the chain status, and you need a way to store information. And after that, it's just a single line where you just create a new engine, here are all the things you need, and the engine starts up.
Let me ask Jonathan at this point. So is there any significant difference here between what might be happening behind the scenes in an Electron Cash wallet or a Selene wallet and what's happening here at this point?
Not much. There is some. In a regular wallet, they might not start from the actual seed. They might have seed words and translate it to a seed, or they might have a different choice when it comes how they want to monitor. Like some wallets want to talk directly with the node, others want to talk through an indexing service. So Electron Cash, for example, talks with the Electrum network with an Electrum server, and FloweyPay talks with a Flowey node. And I know that BitPay talks with a custom BitPay backend indexing server. So it's just a difference in what kind of service is being used.
And there's all of these other services like talking directly to the network and so forth are also eventually going to be totally possible in XO as well. So that's not really a difference, right? Because that's just a matter of choice and implementation.
So the potentially largest difference is the storage mechanic. So in a
Right.
normal wallet, you store on the device you are. Maybe you back up to a cloud, but those things are not always a real-time mechanic. Of course, some wallets do have real-time storage of some data as well. But generally speaking, a wallet doesn't need to have real-time storage in the most common case, because regular wallets today, they don't rely on state for spendability. They don't rely on state for discoverability. They don't rely on state for practically anything other than maybe some human comments that you wrote on your transactions, say like, hey, this is for groceries or whatnot. But the exo stack is different. The exo stack is entirely state based, and it doesn't have a pattern for recovering through a known discoverability mechanic. So instead, if state is lost, then you can quite easily say that essentially all is lost. And so it is very important at this point that we provide mechanics to ensure that the state is safely and persistently stored.
Right. Yeah, I would say that's the big difference too. But as far as like mechanically speaking, things are very similar at this point. It's just that a typical wallet or app probably just doesn't have things separated as much. Like the engine would be just the wallet, right? The whole wallet
Yeah,
is just the engine for the common standard case. All right, thank you. Let's move on.
yes. Right. So the next thing before we can actually start working with our template is to actually have a template. And so what you can do is that you can, in a single line of code, just import the template that you want to use. And once imported, you can now take actions with it. So when you have a template, all templates contains a set of actions that the template can do, but not all actions are equal. Some actions you can do only when you have the corresponding and appropriate state. For example, in an hedge contract, you can't mutually redeem a contract before you have funded it. You can't mature a contract before you have funded it. There are a few actions you can't do before the first funding exists. In a BCH Guru contract, there is a multiple steps you go through before the bet is established on chain. And each of those steps along the way is dependent on the step before it. The exception, of course, being the very first action, the starting point. And so templates also describe the things you can do before you have established any state. And those are listed as just a reference to actions you can do, together with some additional information about what it means to be doing them. In the context of the pay to public key hash article, they are scoped under the owner role, showing that only if you are the owner does it make sense to take these starting actions. So, for example, the customer who might want to pay you, they can't initiate a receive action on their own, because they can't get to the point where they can provide all the data, because only the actual owner is intended to be able to provide all this data.
Well, I'd say on a small technical aside, like they could. It's just that it'll be an
Okay.
empty invitation, more or less, right? It'll be a mostly empty
Yeah,
invitation.
yeah.
Yeah.
So some templates are absolutely going to support taking actions that doesn't have any specific role, and that you can take on roles after you've established the first action. And this is also an important part from many app perspectives, like if you make a web app that helps the user populate these invitations with proper content. You could go to a website and you could fill in all the details of a contract, for example, and then it would create an invitation where it provides the data for what is about to happen, but it doesn't speak for you, it doesn't tell you what the exos to use, and so on. So after you get this invitation, you still have to accept and move on with it and take a role yourself.
And this little bit of conversation is real gold. It may not. I'm not sure if it's obvious or not to the people who are following EXO and trying to to catch on to it and see if they like it or not. But this little thing that we just said is one of my absolute favorite things is the ability to have a trust list set up where I have no idea who you are, but we can coordinate in a way that works and allows me to still uh, make a transaction that I trust, even though I know nothing about my counterparty. So this is a very cool thing. And I would say at this point, with the comparison to the standard wallet, what we're talking about is I think it's called the P2PKH template. And so if we compare this to standard wallet, this would be more or less, this is what a standard wallet understands. And so when we say the template has these actions, the analogy of this would be in a standard wallet, it doesn't even have a lot of other options. All the standard wallet has is basically P2PKH built into it. And so the knowledge, the BCH knowledge that's use case that's baked into this P2PKH template roughly represents the full spectrum of the BCH fundamentals that a standard wallet does today. You think that's a fair say? Of course, the wallets do other things around that, but as far as like the actual transaction construction stuff that that a standard wallet does and that this template does, they're pretty much equivalent at this point.
So I think it's relatively fair to say, but I think you're missing that when we're talking about here is a coordination between two parties, right? You said some kind of merchant who want to get paid and some user that is sending the payment. Now, both of those entities would have to create a bespoke implementation of how to deal with pay-to-public key hash in order to be able to coordinate on this. It's not something that only one of them would need to do.
Yes. But what I mean is this template kind of represents the state of the art of standard wallets today.
Yes,
in
it's
terms
fair
of
to say that,
the intelligence
but it's
that
not
they
actually
have.
entirely true. Because if you look at the state of the art, then sure, if you take modern wallets, you will find these features. But does Bitcoin.com, for example, the largest wallet by millions of users, does it support cash tokens yet?
Right.
But with a
Yes,
simple template, they could.
Right, exactly. So what I'm trying to convey is just to help people following along to have a parallel in their minds, right? Because our audience is technical today, and to just try to keep some kind of parallel where they can see what the engine is doing versus what a typical wallet does. So yeah, it's a very rough equality here, but yeah.
Yeah, but I think you're going too deep on it, because so far we've only talked about like intent and some coordination parts. So actually, this is more like the front end side, like the web app that takes the payment, or the wallet front end, rather than the actual one doing the work underneath, because we haven't really gotten down to the thing that manages keys or creates lock scripts and things like that yet.
Yes. I think it's still going to hold roughly, right, the analogy, in the sense that the things that we accomplish throughout the rest of the story are all the things that, if you've never written a wallet, are all the things that your wallet is doing in the background, roughly speaking, right? They're not done the same way, but roughly speaking, they accomplish the same goal in different ways. But yeah, just as a parallel, as a rough parallel.
It's also worth saying that it is more than just like what people perceive as a wallet might be the core functionality of sending and receiving, but actually most wallets are fairly complex in the sense that they have front-end user interfaces and they have a bunch of settings and whatnot, and there's a lot of things that goes to a wallet that, like, just imagine something as simple as a send screen, right? Whoever makes a wallet has to figure out what to put on that screen. They have to figure out all the user interface relations to it and all the details of like how is the user flow going to be and where do I put the scanner to scan a QR code and all those things. And so a wallet is, I'm just saying that a wallet is a lot more than what we've gotten to by following this part of the template, but also that we're actually starting to describe some of those parts by doing a templated approach now.
Yeah, that's a great detail to explain that. Although yeah, what we call a wallet today is really an amalgam of a bunch of different important parts. And here, what we're really getting into with the engine is like the core logic of the wallet, as opposed to all the niceties and wrapping that make things actually a nice user interface with the wallet.
Yeah.
And then things are going to break down, right? The analogy starts to break down as XO continues on, but a rough analogy. All right, let's move on.
All right. So we said at the beginning, we're going to talk about requesting 100 MUSD, and that there are some starting actions listed in the template. So in the pay to public key hash template specifically, there is a action called request fungible tokens, and that's the one we want for this particular use case. And if we were to look at this one in the template to see like, okay, how does the template actually define this action? We'll see that it has a name and a description, which is pretty straightforward thing. It just says request fungible tokens or request a specific amount of fungible tokens from one or more senders. And it's not that super interesting at this point yet. It does have an icon, and that can help with a bit of user experience. But generally speaking, those parts are just a simple description of things. But it then lists some variables and a transaction. And this is where it starts to get interesting when talking about the actions, because it says specifically here that like if you want to take this action, the following variables will need to be provided. And when this action is completed, the following transaction will have been created. So it has some idea about what is about to happen, as well as an upfront, this is like the outcome that you want to have. And yes, of course, if we're going to receive 100 MUSD, we're going to do it through a transaction so that it happens on chain. And so it makes a lot of sense. If we then go further and ask ourselves, like, okay, so what are these variables, right? The action says I have to provide these two, the requested token category and the requested token amount. So you could just have like an input text field and the user could put in some stuff here, but that would be a pretty bad user experience, and it would be guesswork on the engine to figure out like how to use all these things. So instead, the template actually defines these variables in a very clear way. And you can see in the article that we print out the definition of both of these. And it contains like essentially every other thing inside of a template, a name and description for each part, which means that if you use this and you tell the user, hey, you need to fill in this requested token amount, then you can also provide a contextual description and say what it is. But it goes slightly further and being like also support for the engine itself rather than just support for the user. It defines what kind of data it is. And it says here that the requested token category is some set of bytes, while the requested token amount is an integer, a number. And those are the actual raw things that is going to end up inside of a transaction or on the blockchain. But they are not very helpful neither to the user or to someone who wants to use the engine and create a good user experience. So these variables also contains a third property, a hint. And this hint allows us to provide a little bit more contextual information about what the thing is. So for the requested token category, you can see that the hint is a token category. And so an engine, a user of the engine that asks a user to input the token category, they could either, like before, give you like a text field and you can input the hex characters. But if they do, they can at least have the courtesy of telling you that you try to put in something that isn't a hex character, right? It's supposed to represent bytes, and so hex would limit you, so you can't type in, acrylics or whatever, some other weird character that doesn't belong there. But more importantly, it can actually be used to drastically alter the user experience for the better. For example, rather than giving you an input field where you just type in some things, it might just give you a search field. And you might start typing Moria, or you might start typing MUSD, and it do this predictive little search thing like, oh, I found the token category. It shows you the icon of Moria, and it says Moria parenthesis MUSD, and you click that. And then now you have the app can now put in the correct bytes here. And this is the hint token category, allows the app to do this kind of thing. And on the token amount.
So if I were gonna summarize, the hint is something like a higher level types, right? Like it's not just bytes, but it's like a higher level type.
Yeah, I would say that the type is a low-level blockchain native data type, while the hint is a use case related data information thingy. You could have something entirely different from blockchains here. You could, for example, have a reference to General Protocol Oracle's version 2, or you could have some other very specific thing that's only unique to your specific app and only you understand it. But again, we are in a pay-to-public keyhash template, and so in here we're using hints for the things that make sense from a pay-to-public keyhash perspective. So I'll move on.
So there's this data. Okay. Yeah, there's this data that the engine has now looked at, and it says, okay, I need all this data. And if we're just thinking from the engine's perspective, right? Because the engine, as we have said before, is a somewhat intelligent thing. The engine looks at it and says, okay, I need these 15 pieces of data, not 15, but whatever. And then it's just a spread of data, and that's not very useful. So how does it figure out what to do? I assume that's the next thing you're going to explain.
Yeah. So in this context, we're looking at it from the one making the request, and we assume that they have some specific information about what they are doing and know how to use the template they want to work with. So, for example, you said it was a merchant or a vendor receiving payment. And so what they would do is that they would already know which token category to use. They would have like either a constant in their tooling or whatever. And they would simply prepare these data points. And the next step would be to ask the engine to create a starting invitation. So it would tell the engine like which template, what starting action, and it would provide the variables. And by doing this, it would set up the first communication pattern. Like it would set up an empty data structure called an invitation. It would populate with this field. It would make sure that itself as an entity is listed inside of this. We do a bunch of things, but the most important thing is that it will tell you what template, what action, and it will provide some variables to it.
Now, wait, before it does that, are you going to explain how does our merchant's engine, the merchant side's engine, how does it decide what to provide in this invitation?
Right, so these variables are listed in the action. So it's actually not the engine that is provided. It's the app or the user that provides these variables. But there are more things that are needed to actually get to a working transaction, which we'll get into a moment. Does that answer your question, John?
We're going to get to the answer.
We're going to get to the answer. Yeah, so just knowing what token category and how many tokens you want is not going to get you very far in terms of making a transaction, right? You can yell that with a megaphone on a street, and people will not be able to just randomly generate a transaction for you. And neither would the engine. But inside of the template, we also said that one of the things that the transaction would do is it would create a data structure, a transaction. And so if I am the engine and I have just been told, hey, I want to set up an invitation for this action with this template, I now have to start to figure out what more things do I need to do as an engine. And the thing I would do is that I would start by going to the transaction and say, okay, so this is the thing I need to define. This is the thing I need to create. And how do I do that? And so I go to the template and I find the request fungible tokens transaction. And it has a definition for what it is, right? It has a name, description, and icon. That's the user the user interface and the human aspect of it, but it also contains some specific things related to the transaction itself. It defines the transaction version, the lock times, the list of inputs, the list of outputs, and some other minor things. And with this, it now knows, okay, so I need to set up a transaction structure. So I make an empty transaction, and I set the version to 2, I set the lock time to 0, because that's what the template says that I should be doing. I look at the input, and it doesn't define any inputs I need to put in. I look at the output and say, okay, it needs to have a request fungible tokens output. Template says that this specific output has to be in here. Then I'll have to go one more step deeper and ask the template again, okay, so what is this request fungible tokens output? And in the template, you can find the section that defines this request fungible tokens output. And it's going to say a name, a description, an icon, just like before. And it's going to give you some information about the specific output. It will list a lock script. It will list how much Satoshis should be on it. It will list which tokens and amount. And this is where the template really starts to shine. Because if you look at the category inside of the template, it's not hard-coded. It doesn't say it has to be Moria, because this isn't a Moria receiving template. This is a pay-to-public key hash receiving template. It can receive any token. And so the category definition inside of this request fungible tokens output is actually an evaluation that uses the requested token category to enforce that the output has the token category that the user provided when it set up the variable at the start of the action. And the same goes for the token amount. The amount that is required on that token is also evaluated from that initial data. And so this is a dynamic output. So whenever you want to make one of these transacted uses outputs, the engine will go and put in the right data points in the right places to get to this. This also highlights the first significant user interface improvement that I haven't seen much of elsewhere. And that is that when you're looking at an output in say, a wallet, you will see technical identifiers and technical numbers. And some of these might have some automation around them to provide a somewhat human experience.
Is it just me, or did we lose him?
I'm still
No,
here.
I can still hear him.
Okay, it might be just me.
All right. Twitter is great. Yeah, so in a regular wallet, when you look at a transaction, you look at a specific output, it might say that it's like $15 worth according to some exchange rate at some time. But it doesn't tell you much about what this output is. And it doesn't tell you much about why this output exists, only that it's technically some number of Satoshis that has some kind of value, or some number of tokens of some type. But inside of these engines, inside of these templates, the descriptions are actually also dynamic and can be evaluated from the existing information. And so if you look at it, it's going to say something really crazy. It's going to put a bunch of code inside of this description, which is really, really long. But when you evaluate that code, it's going to come down and create a very simple text. It's going to say something like 100 MUSD requested tokens, or 100 requested MUSD tokens, which means that when you look at this output in the future, you will see that not only does it technically contain 100 MUSD, but you will also see that, hey, okay, this is money I requested. This happens as part of a request that I did. And that information is often kind of lost in the weeds when you have regular wallets. This, for a pay-to-public key hash, might be something that you could overlook. It might not be that important here. But what if you're looking at an NHash contract or a Guru bet or some other thing like a cold run pool? Now, if you have an output there and it says 411 BCH, and those BCH might not be all yours, and you don't know what you did. Maybe you have 5 hedge contracts in a row, and if you look at them, it all says they just went to some pay-to-public key hash locking script. But when you have in the template a mechanic to describe these outputs with contextual information, you can instead, for each of these output, give a clear explanation, something that says, this is a hedge position of $200 for 4 weeks. That text description is vastly much more human readable than just some amount of Satoshis moving to a lock script that looks entirely random.
I wanted to add a small aside here that if anyone is listening carefully, they may have just gotten very, very nervous when Jonathan said that there's a dynamic stuff, as in there's code inside the template, because that sounds like a very, very bad idea on its face. But it's okay, because what we're talking about here when it comes to code is BCH VM code. So this is stuff that operates on a non-blockchain, right? An independent version of the BCH VM, and it's running BCH opcodes. And so it's not like you're just sitting there throwing JavaScript or some other language or machine code into your templates. It's literally just BCH VM script that's running in there.
So having evaluations or having some kind of code inside of a template naturally creates a lot of question marks. One could very simply be what you just mentioned, like, will this consume all my resources and make my application crash or hang? Another one could be, will this ever lie to me and tell me something that isn't true? And there are nuances to this. And as Jan said, the language we are using for evaluation here, Cache ASM, it operates on the same principle as the virtual machine. And so it has the same strictness. It has the same kind of VM limits to make sure that it can't run amok and do a bunch of things it shouldn't be doing. But that does not mean that it's impossible for it to lie to you. Someone can craft a template that is intentionally malicious, that tells you one thing in this description, but then does another thing as part of its actual underlying code. And this is one of the many reasons you should not arbitrarily trust something someone else provides you on the internet. And so if you come across a template in the wild, you should either look for audit or look for reputation information, or try it with a very small sum first to make sure that it does what it says that it does. And then we'll get into the whole trust-related system of the setup in a future article. Because every time we kind of deviate from what we're talking here, we don't get very far in these talks. The reason we only got through the introduction last time.
Let's go.
Yeah, okay. So we had a request fungible tokens output, right? So we had a transaction, it has an output, we need to create this output, and the engine can see most of this. The engine can figure out what the category and the amount is. It knows what value Satoshis is, because these are evaluated from the original parameters provided when you set up the action. But then there is this lock script, which is a reference down to a receiving lock script. So we have to go one step deeper and figure out what is this receiving lock script thing. And due to the way the templates are set up, it's essentially just going to reference one step even further down to an actual script. But when we look at that actual script, it's going to say something that's very, very common in the Bitcoin Cash ecosystem. It's going to opt-up, op hash 60, and then it's going to do a bunch of things, op equal verify and op check sig. And this is the actual pay-to-public key hash script structure. And when it comes down to here, you could argue that, okay, finally it's done. We have finally reached the bottom of this thing, and we can now create this transaction. But no, we can't. Not just yet, because part of that locking script requires us to take a key pair with a private key and a public key, and then hash the public key side and put inside of this lock script. But when you go back and you look at the action, you will see that no such key was provided, right? Only the token category and the token amount was provided. So where's this key going to come from? Well, Actually, the engine is just going to make it up. So the engine is going to look at this owner key, and it's going to look up the definition of this owner key and say, oh, okay, this is a private key. And no one has provided this one to me. And then it's going to take your original seed, right, your original entropy that you provided when you started up the engine, and it's just going to make a key. And then it's going to take this key and it's going to store it as part of its state and say, hey, this key is now mine forever. And it's related to this specific template and this specific invitation. And then it's going to use that key to hash it over to get the hash so that it can create this lock script, so that it can provide the lock script into the output, so that it can provide the output into the transaction, so that it can provide the transaction back when it's time to execute this action. And that's kind of the drill down, all the way down. And if you're asking, and John is definitely going to ask this, if you're asking, how does this relate to a regular wallet? Then the answer is a regular wallet does all of these things. All of these steps are already done in every single wallet in the ecosystem that supports pay-to-public key hash. They all need to figure out how to make a lock script. They all need to figure out how to make a key. The difference is how they go about to do this. In a regular wallet, you have bespoke code. The wallet has said that this is exactly how we're going to do this. In almost every single case, that bespoke code follows a protocol that is defined elsewhere. The most common one being BIP44 in Bitcoin Cash for making the keys, and then just the pay-to-public key as locking script as public knowledge rather than some kind of specification. But in XO, the engine actually does not know what these locking scripts are. It does not know what pay-to-public key hash is. It doesn't know what none of these things are. It relies entirely on the template to inform it about how to do these things.
And this is incredibly important, incredibly important, because when we talk about XO, right, there's a universe of, and I'm overstating, right, but it is roughly true. There's a universe of possibilities on what kind of programs and scripts people can write for money, and what kind of vaults or multi-party systems or markets or predictions or whatever it is that you can do. There's a vast universe of things that are possible and what can be done. But today's wallets have absolutely zero clue about how to do any of that, except for this one thing, the P2PKH template that we're talking about here. So as soon as this template moves to anything else, to any of these other vast array of possibilities, modern wallets today will have zero clue how to deal with it. And that's a big part of the magic here, is the engine doesn't need to know how all these things work, because the templates are where all that knowledge is baked in. And then the engine just uses the template to do the thing. And so the thing is described by the template. The use case is described by the template. And if you have an XO compliant engine written in JavaScript or Go or whatever it is, then now you have access to all of the things that Bitcoin Cash can do.
Yeah. So at the risk of going slightly off topic, today in the payments ecosystem outside of crypto, you can see it as you can hand money from one person to another. You have a bill and you have two hands and you just move it. That's the equivalent of the pay-to-public key hash side. And then you have everything else in society, every single recurring payment scheme, every service platform, every legal contract and document, and they are all touching money one way or another in our lives. When you watch Netflix, you pay for it. When you get your trash emptied once or twice a month or whatever, you pay money for it. When you hire someone to work at your company, there is money involved. But in almost all of these cases, this is handled by contracts that aren't smart blockchain-based contracts, but are rather legal contracts or legal constructs. So I would argue that we're at the point where with our wallets in the existing ecosystem today, we can do that, hand money from one person to another. And we have this vast array of other interactions in society that we cannot yet do. But when you start templating them and making those templates reproducible and verifiable and something that all the wallets can easily adopt, then you move to a state where we are going to eat from the legal contract pie, so to speak, and take over use cases from there.
So I do want to hear I do want to hear you distill it down. I know how this works just from being soaked in it for so long. But today we know that in the wider blockchain space, it is not true that all the wallets, all the wider array of wallets, can't do a lot of things other than send and receive. There are many wallets out there that can do a lot of stuff without understanding any of it. And today, generally speaking, outside of BCH, most of these things are done server side. Basically, you have some very complex and smart setup on a website, backed by some server who does all the things, and then you go there, you can do some very wonderful things, and they will do it for you. They will build everything for you, and then they hand you a transaction and tell you to sign it. What would be the difference and advantage of XO compared to this kinds of modern day setups?
Yeah, you're alluding to the trust situation. Yeah, so if you're looking at all of those, I could snarkily comment and say, point me to one that doesn't have a terms of service, but that'd be snarky and meaningless. So instead, I'm going to actually do what you said. Yes, today, wallet that uses third-party apps and trusts those apps can actually get a lot of things done. A lot of the things that you can do with XO and templates can already be done if you accept the trust trade-off. If you go to a web app and you hand them your money and they do all the cool stuff for you, then you do get the cool stuff done, or you get rugged. You know, it's either or in this case. But with XO, the trust moves entirely out of the hands of the use case and app providers, and now resides exclusively in the hands of your wallet or your application that is under your control.
And to expand on that, or just to restate it, I guess, in another way, because this really is a critical topic that Uname brought up. This is the example we've had before of a loan, right? Where I can go to an app on some website and it says, hey, we're going to set up a loan where you provide the NFT that represents your house, and we're going to give you, 500,000 MUSD, a stable coin. That's the setup. Pretty simple. So you go to the app and you put in all the things and you say, okay, yeah, let's do the deal. And then it sends that deal to your wallet. And in the modern context, your wallet has no idea what's going on. You have zero, unless you are an incredibly technical and deep and dedicated person who has a lot of time to like deconstruct the hex blob that they sent you, which never happens. That just doesn't.
Well, I mean, also you're not gonna deconstruct it by hand. You're gonna have to.
Yeah.
You need to have
you'd have to have tools and everything. And even if you did, you still wouldn't be able to understand things perfectly necessarily. So anyway, they send you a blob and you have no idea. Your wallet has no idea what's going on. And it says, are you okay? And the website shows you these details and you say yes. And you sign it. And at that point, you do not know if the website was telling you the truth, if it was telling you actually what it said was going to happen is the transaction that it set up. Maybe it is. Maybe it is 1,000 times out of 1,001, and then the 1,001th time it does something different. It has a bug, or it's a malicious app, or whatever it is. But you have no ability to verify any of that. With the setup that Jonathan was telling you about, if you listen to how the template has these descriptions on every part of it, and these are human readable descriptions, now your wallet has a large array of content available to it to show to you and be like, this is what's going on. And the wallet can choose at what level of depth or whatever to show that to you. But at the highest level, it's going to say, literally, it's going to say, you are providing this NFT, which represents your house. You are receiving, 500,000 MUSD. And it'll say that. And that description that you get came from your side, didn't come from the app. This is a huge change. The moving the trust from the app side over to your side.
Yep,
Yeah.
and I do want to add that one general consequence of reducing the amount of trust needed. This doesn't just apply to wallets. This actually kind of applies to trusted parties in general. Like if you don't need, a lot of people would say that, oh, okay, so what? I am okay with trusting websites. I don't give a shit about this.
Right.
It is not just a matter of whether you trust this website or not. In general, if you could have a setup that requires trusting the other party less, then you open up the possibility of new types of interactions where you interact with a lot more parties where it's impossible for you to trust all of them. So it is essentially cutting out the middleman. Where previously you need the middleman because you can't trust that many people, so you go to the middleman to trust him. Now you can skip the middleman and you interact with a lot of people where you don't really trust any of them. And so this, for example, opens up to new types of peer-to-peer interactions. And yeah, so this
Yes.
doesn't just apply to blockchains. This applies to real life, and you can see the example everywhere.
This is one of those things that will be in the history books later as the lowering of the cost of trust is going to be one of the key things that crypto or Bitcoin Cash accomplishes. And it's very hard, I think, for us to imagine a future where the cost of trust is low. It's like asking someone in the the early 20th century, what will the world look like when it's massively connected by an internet where everyone can communicate and they have devices that communicate. Someone in 1910 would utterly fail at predicting what the future looks like in that situation. So I think it's going to be similar to one of those where the cost of trust goes down and it changes society. And we don't know all those ways it can change. In this particular case of a loan, one very simple consequence of this lowering of the cost of trust is that instead of having to go to a bank to do a loan, I can go to some literally random person. I have no idea who they are. They're a AI, or it's a human, or it's a bank, or I don't know. It's an alien. And I can make this loan with them just as well as I could with, a mega bank today, because the cost of trust is very low here. All I need to do is have my template that says, yeah, this is the deal that's being made. And that deal is just as good, whichever my counterparty is. All right. Jonathan, I was thinking to go through a little recap of things and then have you tell me if I've got things right. But would you like to continue down the rabbit hole a bit further, or do you think we got to a stopping point on this one?
So we're actually at a point in the article where there's a natural stopping point. We're at the point where we have created an invitation that we can share. It's all the data that the vendor in this case, the merchant, can and need to provide until the invitation is done. And it's now time to share that invitation and start looking at how does the other side handle it. So if you want, please do a recap because that's actually helpful at this point.
Okay, I'm going to anthropomorphize things because I think that makes it easier to understand. So there's several parties here. There's myself, the merchant, there's the engine, my engine, which I'm just going to call my engine. It's on my side, my teammate, my wallet, my engine, and the template. The template is shared, right? Other people have this template also. And I want to receive 100 MUSD for some transaction that I'm doing on some e-commerce website, whatever. And so what I do is I have my wallet, and I tell the wallet, hey, there's this thing called receive fungible tokens. I want to do that. I want to receive 100 MUSD. And my wallet says, okay, we've got a template that does that. We're going to use this action in the template. And the wallet then takes the template and that action that we've chosen, and it feeds it into the engine, my side's engine. And the engine says, beep, boop, beep. All right, this is all the shit that I need in order to achieve this transaction. These are all the things. And there's a handful of these that I already know how to provide because you're the person who's receiving. So we are intending to receive this MUSD. So it fills in a bunch of data into this invitation, and a whole invitation that has all the things required. It fills in the parts that I need that we already know, and it has that packed up. And now it says, okay, who are we giving this to? Who's going to take the other part of this invitation and fill out the rest of it so that we can accomplish this transaction? Is that a decent story? Did that about get it?
Yeah.
All right, let's keep going.
All right. So we have an invitation and we're handing it over to the customer and say, here, this is what I want you to do. And so the customer opens this invitation and looks in it and it's like, okay, before I start to handle this and actually do something, I kind of need to know, is this really what I want to do? And if I want to do it, what will that actually mean to me? What will happen with my wallet? And can I even do this? And so there are a couple steps, technical steps, that the wallet will do. And so one of the things it will do is to check, is there any particular roles I can take in this invitation that is not already occupied? And in this example, there's none. In other templates and other actions, you might have multiple and you get to choose, so you could take on more than one role. But for the sake of this one, there's actually no particular role. So we're done with this part and we can kind of move on. And then we can say, okay, I'm going to accept this invitation. I'm going to say, okay, this is an invitation I want to take, I want to be a part of, but I haven't yet figured out what will it mean to me to actually be here. And so I need to figure out what are the requirements for completing the action in this template. And so I can ask the engine, like, here's the invitation. I accepted no specific roles in this invitation. What's left for me to do? And what it will do in that case is that it will figure out from the transaction that there are some things that still need to be done in order for that transaction to be valid on the blockchain. We had a locking script for the output, and we had amounts in that output, but the transaction doesn't have any inputs yet. And so someone will need to provide any inputs. And if you want to be the one that completes this action, then you are going to be the one that needs to provide these inputs. And the engine itself will back calculate from the outputs to figure out how much value do you need to provide in your inputs to fit this kind of situation, to resolve for this. And so it's going to look at the specific token category and amounts and things that were listed in the invitation, the actual numbers, and it's going to back calculate to get to a point where it knows that, okay, so I need this many Satoshis, I need this many fungible tokens on that category, and this many non-fungible tokens. And so you'll get a list of requirements, like a technical list, as the wallet when you're interacting with the engine. And then you can take the next step, which is to tell the engine that, okay, could you find me and reserve some resources that would be used for this thing? And the engine will look at your unspent coins and it will determine like, yeah, you could use this coin, or you could provide a list of coins if you wanted to be specific about what coin to use. But in this example, we're just gonna ask the engine, do all the work for me. Find all the coins needed to satisfy the rest of this invitation. And the engine will then look through your unspent coins. It will find coins that are large enough. It will select some coins, and it will put those as inputs in the invitation. And it will also put change outputs for them based on where they came from, or based on some policy you might have in your wallet about where you want change to go. And the reason why I said that this is called reserve resources is because we don't yet have a transaction on chain. So the outputs have not yet been spent. So the engine will mark these as the following resources are now frozen. We have reserved them for this specific invitation. And should this invitation expire or be canceled, or actually just complete, then this reservation is no longer relevant. And so can cancel that reservation if no one does anything. And when it has done this reserve resources step, you now have a list of the exact inputs that comes from you and the exact outputs that goes back exchange and everything. And so now is the point where you can actually go to the user and say, okay, hey, you said you wanted to work with this invitation over here. This is what it means for you to be a part of this invitation. It's going to take these funds from you, and you can look at those funds, and if they come from, and they have to because it's in the Excel, but if you look at those funds, you will actually have description of what funds it is. So for example, if one of them is an hedge contract that has matured, it will say that it's a matured hedge contract output. And you can see for each of those output what they are, and you can see what the change go back, and all of these have descriptions on all the parts. But you can also, as a wallet maker, do the traditional way where you sum up the net result of the action. Say like, okay, you have this many 100 MUSD less and some thousand Satoshis left after this transaction has been completed. And if the user agrees and thinks that this action is good, you move on to the step where you sign this invitation. And this is the step where you actually provide the unlocking scripts and all the signatures required to spend any money. Prior to this, it was all theoretical and we prepare to do something. But at this point, you have now created an actual, like fully completed, you can now do this thing. And you can either then send that back to the merchant, so the merchant can inspect it and tell you whether you did good or did bad, because the merchant might be able to help you avoid some mistakes if they want to. Or you could, because you have all the information, you could just go ahead and execute the action. And no matter who executes this action, it's going to create a transaction, and you'll broadcast that transaction on chain, and that completes the invitation process, right? We started from the beginning with what we want to do. We figured out who the initiator is, what data they needed to provide, what data the engine could figure out on its own in order to craft that locking script. It set up all this state and prepared everything and made that invitation. We sent the invitation over to the payee, and the payee looked up all the requirements on it, took on whatever roles it wanted to take on, provided whatever variables it wanted to provide, and then reserved some resources to be used in this one, and then finally signed off on, yes, I want to do this, and the action got executed on chain. That's kind of like the whole walkthrough in a nutshell.
And a critical thing that goes back to what Jonathan said about state is that at each step of this process, there wasn't a strictly defined process, so to speak. It was just an invitation that needs to be filled in. However it gets filled in is fine. And there's usually going to be obvious ways to fill it in. But whatever it is that happens, however it is that you do it, because everybody has a different process, sometimes they're going to be like an accountant between you and the signer, like the accountant deals with the details and the executive does the signing or whatever. The process can be varied here. But at every step, there's state that has been stored and synchronized, and we know what's going on at every step. So there's no point where you're just like, I don't know what's going on. We're not sure what happened. All of this process gets tracked without having to have a strict process itself.
Yeah, although that's for the next article, which is already out, by the way. So if you're interested in the state management side and how to determine ownership, it's a great read to move on to the Vision to Reality 2.
Yes, that
But I don't
article is
think we should
already
do.
out.
Yeah, we're already a bit over an hour though, so maybe we shouldn't deep dive into that one just yet.
Yeah, no. I just wanted to make sure that people who are listening, who may be worried, right? Like, wait, I thought all this state stuff was there. I just want to mention that, yes, it's all being tracked. And not only is it being tracked, but it's being tracked in a much more meaningful way than happens with modern wallets today, because there's less of a need, right? Like everything is just all anyone does is P2PKH or maybe some kind of multi-sig setup, very basic multi-sig setup. And if that's all you do, then there's a lot of this stuff that happens that is just based on assumptions. Well, of course, that's what's going to happen next. Well, of course, that's what's going to happen next, because that's the only thing I know how to do. But once you get out of this mode of having only one way of doing things, you have to be very smart about making sure you know what's going on at each step, and who did what data did they provide, etc.
Yeah, I actually think it's kind of funny how Bitcoin and a lot of other cryptocurrencies, they kind of started from that like predictive discoverability mode, where you start from a single entropy and then you follow some protocol to discover all your on-chain activity. And it's a really cool feature. But if you look at the wallets that people are out there using and what they like, you'll see that people like putting context on things. They want to put their own, like, what is this? They want to have their explanation, and they want to put it into groups and have summaries and do data analysis on it. And all this extra information that these wallets allow for is state that is not derivable from that original entropy. And so these wallets, they do eventually cater to the user needs, and they set up their own synchronization services where they store this state. And yeah, I mean, if you already do that and it works well, if you just go a little bit further and drop that requirement for discoverability and figure out a good backup system that utilizes this state synchronization, you can open doors widely and get access to a ton of new things.
Yes. All right. So Bitcoin Cash Podcast has joined us, and let's see what he's going to throw at us.
Hey guys, I love hearing all this. I'm so unbelievably excited for the XO stack and wallet templates and all of that. And I'm thrilled because I think it puts BCH in such a strong position that at the scale we're at, right, we're doing a reasonable job in the cryptocurrency industry, but to get converts, we have to be offering something that nobody else is, that is much, much better than anybody else is. And then we obviously have to package it up nicely and promote it. And I think this is absolutely moving in the right direction. I'm working on a theory that maybe 2026 is going to be the year that BCH finally starts getting some serious on-chain network effect. We've recently seen a little bit of a bump in on-chain activity, and between all the different things going on, it sort of makes sense. But my question is more about finding ways to explain all of this, because like you said, you've got several very complicated blog posts and so forth going through all this, and people are not really going to understand it at that level of detail, most of them. And they're, we kind of need ways to really communicate to people in a very simple couple of examples or sentences why this is so much better than everything that's on the marketplace. So I was thinking about that. And my one idea I have is that for developers specifically, like in other cryptocurrencies, if we were trying to get them, you could sort of explain it as like a type system for blockchains or for cryptocurrency transactions, which you guys actually touch on a little bit before. I think that might be one way. You know, there's so many people who use JavaScript and TypeScript, and they understand why you would want to have TypeScript. It makes things safer and easier and less error prone and more easy to import between different projects, more easier for other developers, all that sort of stuff. So that's one concept I had, but I don't know if you have any other concepts for how we can really explain to people the importance and enormity of this to get them curious, either for developers or just for general audiences.
I have a take on that. So if you go back to the early days of Ethereum, and you know my example of somebody back in 1910, and you ask them to explain what does the world look like with the internet, they would utterly fail. And roughly the same was true in the early days of Ethereum, right? If you took somebody with the early days of Ethereum, the tag phrase was the world computer, and they had no idea what they were really going to do with it. And if you tried to explain to them how like all the MetaMask and protocols and libraries and services and infrastructure, like how all of that stuff would have worked, again, somebody then would have pretty much utterly failed at describing what it looked like. And so the reason I say that is because once something builds up, all of those things become assumptions, and it becomes obvious to the people who are doing it, who are builders and entrepreneurs. And it's not really something that needs a lot of explanation, right? It's all there, and it's just the water that you breathe. So at some point, it will reach that point where it's all so built in and so standardized that you won't even, it'll just be common knowledge for everyone. But getting there is definitely an issue. And so the articles we're posting will help with that. When it comes to an analogy, there's two big things. There's one is the safety that I mentioned before, which is the current, in terms of something that nobody else offers. Nobody else offers a wallet where the wallet is truly on your side and all the transactions that you make are truly understandable by your team, by your wallet, your engine, and yourself. That's something that we're offering. So this is a safety thing that is necessary if you're going to reach 1 billion people, right? You can't have average people trying to understand technical transaction details. Absolutely impossible. You can't even have engineers trying to understand it. So that's one unique thing. The other is that with the templates, they're providing the protocol and the use case, and all that knowledge is baked in. The BCH knowledge and the use case knowledge is all baked into the template. And now this is something that you don't have to know to build an app. And so in the EVM world, this would be like the reason that you see clones of the same protocol over and over and over again, because they're quite valuable and useful. And a lot of the people building apps that use those protocols don't really understand in full detail how those things work, but they use it. And so that's the other thing that this is going to provide for UTXO that doesn't exist for UTXO systems, is where developers don't need to be so deeply aware and understanding of all the details of what a protocol does. All they need to do is have the template and write an app that uses the template. And this massively lowers the cost of developing apps and developing financial contracts and financial systems and economy on BCH. So massively lower cost for entrepreneurs and builders, massively higher safety that doesn't exist anywhere else. Those are two big points that are worth putting out there to attract people.
So I think we need two things, and those things are great, but I think we need two different things. I think we need successful products, and I think we need successful stories. So a successful product is something that uses the system that couldn't exist otherwise, that ends up getting traction with users. So if you have a wallet that can provide all the benefits of this, and it allows you to do, say, Cauldron in a very, very good way, and people start using that app, what's going to happen is that they're going to go to their other wallet providers, and they're going to say, can't you do this, please? This looks really good. Please do this. And those wallets makers are going to look at the first thing and say, how did this happen? Where did all this magic come into place? And then they're going to look at the XO libraries and like, holy shit, let's build a new wallet, or get outcompeted. The other thing we're going to need is the successful stories. And as Jan said, the cost of building after you have a templating system is massively lower. I mentioned this in the second article, but I'll just highlight it here. The Anyhedge library is something like, I have the actual number here. Let me just scroll down and get to that number. Yeah, it's 262 kilobyte large. That's 262,000 bytes large, that library. It took us almost 3 years of pretty dedicated working on it and a lot of maintenance after to get to the point where it can do what it does. And it does more than just the templates. But if we had the templates, then I think at least 2/3 of that library would not be needed. And that would have saved us so much time and resources. So when we get this out there and people start building with it, it's gonna, like, by comparison to what they are used to, it's gonna feel like a cakewalk. You might need to hire someone who's good at writing a template, someone who's good at the contract language and the virtual machine to get your initial template going. But after that template is done, you can literally hire whatever front-end developers you want from whatever place you want. You can build cool apps on Fiverr. That's kind of the difficulty level once the template is in place. And you don't have to make your own templates. You can use templates that already exist. A lot of people think that, like, it would be so good if we had a wallet that just looked different. Does everything that every other wallet does, that, but looks something that fits my case. And to make a wallet from ground up is a ton of work. But when you have the pay-to-public key hash template and you have the XO engine, making the technical side of the wallet might be 50 lines of code. And it might be very easy to use code for a developer that isn't a specialist in this field. And so you would spend all your time building the front end, building the things that you really care about, the thing you want to actually deliver, rather than fighting all the underlying, like, low-level things. So yeah, so that's what I think. I think we need products that are successful so that people, leave unsuccessful products behind, and stories that are successful so that people go build those successful products.
Yeah, I agree with both of those. I think that's true, and that's going to be a very important phase of it. Certainly, yeah, making it much easier technically helps, and expanding sort of the rate of innovation by the lower cost, all those things help. What I'm sort of thinking about is, like, we're at the step before that, right? Which is that XO currently exists as a blog post that people in this space know about, and a couple of others. But even before we have those proof of concept, of course, it's sort of like a build it and they will come type of answer, right? Once we have all this stuff, everyone will be really impressed to jump on board. And of course, it's more powerful to show than tell. But right now, we're basically at the stage of telling, and we are going to be for the next several months at least. I liked what you said, Jonathan, about the legal system. I liked that a lot, basically saying that all of the legal contracts of any arbitrary complexity or any kind of, financial vector or whatever can be simplified into these templates to really give people, because there's been so many years in the cryptocurrency industry in general, this is the future of finance. Imagine if, the money was smart money on the internet and all that. But a lot of it hasn't really come true, okay? Like at the fringes of DeFi, a little bit, yes, but the average person doesn't give a crap about any of this because it's way too hard to use and it doesn't just make intuitive sense to them. So I think at this point, we're still trying to find a way to explain that, how to get people's eyes to light up about it a little bit. And maybe, that legal sort of analogy, because people understand how much different stuff goes on in the legal and accounting world, some way of linking that to the XO stuff. I haven't figured it out yet myself, but some kind of simple way of analogizing or explaining that, I think, is needed.
Yeah, we'll hopefully get there sooner rather than later. What I can say for now is that a picture is worth 1,000 words, they say, and I have written articles of thousands of words now because I'm on the technical side, but we are also working on the picture part. I don't want to spoil too much, but if I say like this, in Selene Wallet today, if you wanted to make an overview page that could give people a pie chart of where their funds are, and they are doing liquidity pools on Cauldron, could you do it?
Well, we could, but it would take, a shitload of work, obviously.
Yeah. So that's actually the next picture that we're probably going to share sooner or later, is how the XO provided the underlying requirement for giving your wallet an overview that can tell you what your ownership looks like across all possible contract systems, where it can tell you that 13% of the value that's to your name is in liquidity pools on Cauldron today, 45% is in hedge contracts, and that updates automatically from on a day-to-day basis. That's
amazing.
Without doing an insane amount of work. And for us, once we have it, if the user adds more templates, it's the same exact mechanic underneath to get all the data out and to just update it. So we can go from having that for one protocol to having it to 15 protocols by just importing 15 templates.
Yeah, I love it. I love that idea of a picture is 1,000 words. And yeah, simple like pie chart in a wallet of your funds broken down into, different kinds of stable coins, gold, assets, on-chain tokenized, this and that, LP pools, any hedge contracts, spare cash funds, reserved, UTXOs, cash fusion coins, whatever. Like that's very cool. That's definitely the right direction. Very good idea.
I'll add one additional point that I'm personally in love with, and I believe Jason Dresner also agrees with this type of idea, which is that, I'll just say it from my perspective, but so the P2PKH, the way that 99.99% of money moves around in crypto, especially in Bitcoin Cash today, or all of crypto, but including Bitcoin Cash, is really not a great design. This is the equivalent of somebody who's wealthy having millions of dollars just stuffed into their wallet. Maybe one of those wallets is sitting at home and one of those wallets is in their pocket, but either way, it's not a great setup. And the multi-sig that we have is kind of a very small step away from that. It's not an amazing step. It's a pretty good step, but it's not amazing. And so, but the P2PKH is absolutely, by far, no question, the dominant standard of how money is held, which is this simple wallet analogy. So with XO, you get to a place where I can have my wallet say, you know what, let's not do that anymore. By default, whenever I deal with money now, that money is going to go into a special vault. And that vault works in the following way. Like it can spend, this is according to my rules, right? Like not some bank's rules. It can spend, up to $100 a day. And if it ever tries to spend more than that, it's going to need some additional authentication or authorization, which, whatever that is. And if you ever want to take out a very large amount of money, then that'll also need an additional procedure. Maybe you have to wait like a week before you can receive the money. And this, again, is your rules, not the bank's rules. Whatever rules it is you want to set up. And so this creates a much safer situation for all of the money that's locked up in Bitcoin Cash. And with XO, each wallet could have their own opinion on that. This wallet uses the the super Jason Drazner vault, and this one uses the super quantum resistant vault, whatever it is. So yeah, you get to a place where wallets can transparently just choose a different type of default way to handle money, and now your wallets are just massively more powerful than they were before.
And you get mechanics to transition from one to the other
Yeah.
in a simple way. I think earlier we made a comparison between XO and regular wallet where it said like, oh, all this work that we just went through, a regular wallet would also do it. But with XO, the engine actually doesn't know. The engine relies on having a template explain to it what to do. And I think this is kind of the point that John is hammering home here really well. And is that you don't have to give the engine a pay-to-public key hash wallet. You can give the engine whatever templates you want. And the templates that you tell it to work with, it's going to use. And so if you care about quantum resistance deeply and you want to be first online to get quantum resistance for your money, then all you would need to do is to import a quantum resistant template and say, this is what I want to use, and then not use the pay-to-public key hash part and just use the one you want to have. And this also, like, you can easily say that, yeah, it makes sense for these big things, but actually this makes sense even for very, very small things. If you want to have a pay-to-public key hash with a 2-day delay on everything, just so you get 2 days to say no, whatever, some very, very simple type of vault that uses pay-to-public key hash underneath, and that's just very, very slightly different. You just install that template instead of the other one, and now you have that. Yeah.
Yeah. All right.
Very cool.
I think we should wrap it up here, and we're going to get into the state probably next time, as Jonathan mentioned, for the other article. So yeah, thank you everyone for joining us. Jeremy, is there anything you wanted to wrap up with before we close?
No, just this all sounds great, and if anybody is listening to this and wants to get involved in hacking on BCH, check out BCH Plays at BCH Plays on Twitter and get involved in that, because I don't know that XO is going to be specifically involved in that right now, but you can get a jump start on being ready for all this when it drops by hacking on BCH now, so come get involved.
Yeah, I'm just going to say that that's a great idea. I think anyone who listens to this after the fact and is still in time to actually go join Blaze should take a look at it at least. Even if you don't get to use XO at it, what you will learn from working with the BCH scripting language and contracts, you can then apply, put into a template when XO comes out. So it's a good first step to onboarding XO anyway.
All right. Thank you, everyone. I hope you enjoyed it. I have actually greatly enjoyed this, just listening to Jonathan tell the story and then taking part in that. And I love that I get to have a small role in this thing that's unfolding. So thank you all for joining us, and thank you for the listeners who are checking things out after the fact. We'll have all this posted for you on all of the normal social media streaming platforms soon. Take care, everyone. See you next time.